Sample diploma questions. Which of the following statements best describes an isolated system? So for a system to be an isolated system, it has to have no external forces. External forces. If it has no external forces, it is an isolated system. Okay? Isolated systems will have momentum conserved, but for it to be an isolated system, it needs to have no external forces. So that's what makes A a better answer than C, because which of the following statements best describes an isolated system? Well, an isolated system is one with no external forces. Because the cart bumper system has negligible friction, so negligible friction means no external forces. That means that it will be an isolated system. Because the kinetic energy in the car bumper system is blank, the collision can be identified as blank. So it says that it's a rubber bumper in the question. And rubber bumpers, we know rubber will squish. Anything that squishes shows that there's evidence of inelasticity. So if there's inelasticity, kinetic energy will not be conserved, and it will be an inelastic system. Okay, the maximum speed of the three-car system immediately after the collision. So a lot of people when doing this question, they'll go from 1 to 2 and 2 to 3. You don't have to do that, right? Because the sum of all the momentum here is equal to the sum of all the momentum here is equal to the sum of the momentum here, right? The sum of our momentum is going to be the same in all three scenarios, right? So if the sum of them are all the same, then we can go straight from 1 to 3 without any problem, right? So now if we use physics principle number 4, where our momentum before equals our momentum after, before we just have the momentum of car 1. And then after we have the momentum of 1, 2, and 3. So this is M1, V1. This is M1, 2, 3, V1, 2, 3. So if we want to find the speed of V1, 2, 3, then we just have to do that. So I'll plug that into the calculator. So we do mass 1, which is 1.5 times 10 to the 3. We multiply that by the speed of car 1, which is 4. And we divide it by the combined mass of all of them. So 1.5 times 10 to the 3 plus 1.2 times 10 to the 3 plus 1.8 times 10 to the 3. And we get 1.33. So our answer is 1.33. Okay, this one here is a Newton third law question, right? This one's heavier, this one's going a smaller speed. Same initial speed, so they go in the same speed, but this one's heavier. But when they collide, when this collision happens, you have to know that force 1 is equal to force 2. These two arrows are the same size, even though I did a bad job of drawing that, right? And then impulse, which is a vector, is equal to force, which is a vector, times time, which is not a vector. So whatever direction our force is gives us a direction of our impulse. So the only answer is equal and opposite A. Okay, so let's do our last lesson in momentum, collisions, and explosions in 2D. So curriculum, do the same thing we did last lesson, except with two-dimensional interactions in an isolated system. So any collision or explosion that does not proceed in a straight line must be considered a two-dimensional collision or explosion. Right? And when we have a two-dimensional collision or explosion, we have to break things down into X and Y components, solve individually as two separate problems. So we're going to do our 2D problems in RCS angles, and you have to remember that with RCS angles we go 0, 90, 180, 270, and then we go counterclockwise in that direction. So you got to be familiar with RCS angles to do these questions. But the very first question that we're going to do, you don't actually need to do in RCS angles because it's an easy one. It's an east, north, southwest sort of right angle question. Okay, so we're going to do this one together. I'm going to switch to my whiteboard. A 4 kilogram object is traveling south at a velocity of 2.8 meters per second when it collides with an object traveling east at 3 meters per second. So just like we did the questions yesterday, we're going to draw out a before and after. So the first one is traveling south. And it's 4 kilograms, traveling south at 2.8 meters per second. And then our other object is 6 kilograms, traveling east at 3 meters per second. If these two objects stick together, what velocity do their combined masses move? So if they stick together after, it's going to be going in this direction, right? So what we need to do, well, the easiest way to start this question is we know that momentum is equal to mass times velocity. So when you're doing these questions, there's a lot to do in these two-dimensional questions. It's easiest if you just find your momentum in this step, right? So 6 kilograms times 3, I can do that in my head. That's 18 kilograms meters per second. 4 kilograms times 2.8, I can't do that in my head. So I'll go 4 times 2.8 is 11.2. So this is 11.2 kilograms meters per second. So do that to start. You don't have to do that to start. It just makes life a lot easier. Now, what physics principle number 4 says is that the sum of our momentums before is going to equal the sum of our momentum after. So what I'm going to do is I'm going to find the sum of that momentum before. And in Physics 20, we learned how to add two vectors that are going at right angles, right? We have to use tip-to-tail vector addition. So my first one has a momentum of 11.2 kilograms meters per second. And then my other one has 18 kilograms meters per second. Right. And then this is the sum of my momentum, right? That's my total momentum. So I can't just add them up. I have to use 11.2 squared plus 18 squared and square root it, and then I can find what the total momentum is. So I will do that. 11.2 squared plus 18 squared, and I square root my answer, and I get 21.2. So this is 21.2 kilograms meters per second. And I can also find this angle here by going tan negative 1 of opposite over 8 adjacent. So I will do that. So tan negative 1 of 18 over 11.2. And I get 58.1 degrees. So this is 58.1 degrees. And that's going to be, I'm not going directly south, I'm going east of south. So this is my momentum before, right? This arrow here represents my momentum after. So this one right here is going to be 21.2 kilograms meters per second at 58.1 degrees east of south. Because the law of conservation of momentum says it's going to equal the momentum after, and this is the momentum after. Now the only thing that we have to do for this last part is it wants to know, it doesn't want to know this momentum, it wants to know its speed. So we know that they stick together. This one's 6, this one's 4, so this one's 10 kilograms. So all I have to do is use P equals mv, divide by mass, take my 21.2, divide it by 10 kilograms, and I end up getting it's 2.12 meters per second at 58.1 degrees east of south. And then that is my final answer. Okay. Those ones are the easy ones. Those ones should be pretty straightforward to do. So this question is a lot more difficult than the last one. So we have a 150-gram ball moving 5 meters per second east when it collides with a 120-gram ball moving 4 meters per second north. After the collision, the 150-gram ball moves there, and we want to find information about the 120-gram ball. So this is a lot more difficult because they don't stick together, and now all of a sudden we have 25 degrees north of east. That's not as easy as the last one. Okay, so again, we're going to start with drawing out our before and drawing out our after. Okay, it just helps organize things in your head, what's going on. So our 150-gram ball is moving east. And it's moving at 5 meters per second. And then we have a 120-gram ball. It's moving north at 4 meters per second. Okay. Let me just make this one a little bit bigger so you can see 150 gram. There we go, that's better. So after the collision, it says 150-gram ball is going 25 degrees north of east. This is east, so it's going this way. This is 25 degrees north of east, and it's going 3.2 meters per second. And this is our 150-gram ball. Right, so the other ball, we want to find out, you still see that, yes, 120-gram ball, what direction, what speed is it going? That's what we need to figure out. Okay. So again, what I'm going to do is I'm going to use P equals mv, mass times velocity, and these are pretty easy to calculate because 150 times 5 is 750. I can keep it in grams as long as everything's in grams, so this would be grams meters per second. So that's my momentum of this. And then this is 480 grams meters per second. Don't even need a calculator for that. And then this one here, 150 times 3.2, I do need a calculator for that. It's 480 as well. So this here has a momentum of 480 grams meters per second. Okay, so find their momentums. Again, you don't have to. It just makes things cleaner, nicer, neater when you're finding stuff. So we're going to use physics principle number 4. Sum of our momentum before equals our sum of our momentum after. But because this is a complicated two-dimensional problem, we're just going to add those x's there. So we have to find it in the x, find it in the y. So before, we have, let's call this 1 and 2. 1 and 2. We have momentum of 1 in the x. And we have momentum 2 in the x. And I know a lot of you might be saying, well, this has no x, it's going straight up. Just put it in there. It'll turn out to be 0 anyway, just because it makes life easier in our calculator after, right? And then after, we have 1 in the x after, and 2 in the x after. Okay. So we know momentum 1 is 750. And to make it in the x, if we're in RCS, we just have to go cos. So let's put in our RCS angles as well, right? This is going to be 0 degrees in RCS. This is going to be 90 degrees in RCS. And this one's going to be 25 degrees in RCS. So to find in the x, I just have to go my 750 grams meters per second. And then x, to make it x, I just go cos of 0. And then for the second one, this is 480. To make it x, I'm going to go cos of 90. And if you type cos 90 into your calculator, you get 0, and that's why it zeroes it out. Sorry, I jumped the gun a little bit. It doesn't mean anything. But we're trying to find out the momentum of 2 in the x. So what I'm just going to do here is I'm going to subtract it from both sides. And when I do that, it moves over here like that. Sorry, I wanted to do that before. It's better to isolate what you're trying to find. And my advice to you is do not break down. I find students make a lot of mistakes and they get confused if they break that down. Just leave that as momentum 2 in the x after. Don't need to break it down. Okay, so now that this is over here, so we subtract P1, which is 480 grams meters per second, and then to make it x, we go cos of 25. Like that. So now what I'm going to do is I'm going to plug that all into my calculator, all in one step. And do it all in one step because you'll see why in a brief second, why it's better to do that all in one step. So we have 750 cos of 0. Type it in like that. You don't need extra brackets. This will get you the right answer, I promise. So 480 cos 90. And then we subtract 480, just happened to be the same, just a fluke, cos of 25, like that. No extra brackets, nothing else needed. Right? So what we get is we get the momentum in our x for 2 after is 314.9. And I'm going to use that whole answer. Everything's in grams meters per second, so we're going to keep it the same. So the reason I want to put it all in one in my calculator, the reason I want to include that is because now when we want to find the y, we just go 750 sine of 0 plus 480 sine of 90 plus minus 480 sine of 25, right? You just do the exact same thing, but sines to find it in the y. So now that I've already typed it into my calculator all in one step, I just go second enter. It'll type in the last thing I just typed in. I switched all my coses to sines. Switch this to a sine. Just highlight over the C. There we go, push sine. Switch it all to sines, and we get 277.14. Now that we have that, we can draw our final triangle. So both of these are positive. So positive is up and to the right, negative is down and to the left. So I'm going to draw my x as positive, 314.9. And this is slightly smaller, but still positive, 277.14. And then this is my momentum 2 after. Okay, so what I'm going to do is I'm going to take that 314.9, square it, plus 277.14 squared, and square root it to find it. And again, I'm using my full answers because I have them in my calculator here. So I'm going to take that squared plus that squared. And then I'll square root that answer to get 419.5. How many sig digs? We had 1 sig dig in this. Ooh, I got to change that. Whatever. I'm just going to say 420. And that's grams meters per second. And then to find that angle, I'm going to tan -1. Right? I want to find this angle here with no arrows. So it's going to be opposite over adjacent. So opposite is the 277. And adjacent is the 314. I'm going to close those brackets, and I get 41.3 degrees, and that's going to be north of east. I'm not going east, I'm going north of east. So that's wonderful, but you have to remember that that's not what they're asking for in the question, right? They're asking for the velocity, but all you have to do to turn that into a velocity is use P equals mv and take your momentum. Oh, I was off screen a little bit. Take your momentum, here, I got it up here, and divide by mass. So I have to take this and divide it by the mass. So I'm just talking about 2, which is 120 grams, and I'm in grams meters per second the whole time. So if I take my 420 divided by I'll take my full answer, 419.5, divided by 120. Then I end up getting 3.5. Sure. Sig digs don't matter in this because I have one sig dig. So 3.5 meters per second, and then the direction is the same. It's still going to be 41.3 degrees north of east because the mass doesn't have any vector quantities to it. And you get your answer, and that is how you do that. So now we are going to give a board question here. A stationary fireworks ball exploded into masses. The first 1 kilogram mass flew off at a speed of 300 kilometers an hour directly east. Second, at that direction, and the third, we want to find the speed and direction, so basically the velocity of the third 2.5 kilogram mass. Okay. So try this on your own, see how far you can get, and pause the video, and I will do it right now. So a stationary fireworks ball exploded into masses. So we need to do a before and after. So this is a two-dimensional explosion, and before, we just have a stationary firework, right, with mass 1, mass 2, and mass 3, right? They're all together. And then after the explosion, it says that the first mass flew off directly east. So this piece here flew off directly east, and it's 1 kilogram, and it flew off at 300 kilometers per hour. Okay. The second piece is 1.5 and flew off north of west. So this is west, so I'm going 30 degrees north of west. And it flew off at 250. And it was 1.5 kilograms. Yeah. And then our third piece is probably going to fly off somewhere like that. That's what I would guess. Right? It's all going to end up equaling 0. So now we can use physics principle number 4, where our momentum before equals our momentum after. And we're going to solve in the x, and we're going to solve in the y because it's a two-dimensional problem. So before, my momentum was 0. All explosions, it'll be 0 before. And after, I have momentum 1 in the x, momentum 2 in the x, and momentum 3 in the x. We want to find out momentum 3 in the x, so I'll subtract p2x, subtract p1x from both sides. Right, so then what I end up with is negative p1x minus p2x is equal to p3 in the x. And these are all after, but there's no before, so it doesn't really matter that much. So I can break these down into mass times velocity, but why? Let's save myself a little bit of time. So this is 1 kilogram times 300. I don't have to change any units as long as they're the same. So this is a momentum of, right, we're using P equals mv. So 1 times 300, kilograms, kilometers per hour. And then it's going straight east, so that's going to be 0 degrees. So that's the momentum of 1. And then 2 is 1.5 kilograms. And then it's going 250. So this, I'm just going to put my after up here, has a momentum of 375 kilograms, kilometers per hour when I do the mass times the velocity. And then my angle, right, 0, 90, 180. And this is 30 degrees, so it's 30 less than 180. So it's going to be at 150 degrees. And then we want to find information about 3. So now, to make it in the x, all we have to do is we have to go negative 1, which is 300 kilograms, kilometers per hour. And then you cos the 0 to make it x. And then we subtract P2, which is the 375 kilograms kilometers per hour. And then to make it x, we just have to cos the 150 degrees. And that's going to equal P3x after. So now we plug it into our calculator, put the negative in front, 300 kilograms kilometers per hour at 0 degrees. We subtract 375 cos of 150, and then we get our answer, which is positive 24.75. So that's going to be our momentum of 3, and the x after is the 24.75. And obviously I'll use my full answer. It's in kilograms kilometers per hour. So now the reason that we typed it in the same is because, well, all we have to do is we have to write out the exact same thing, but we just have to do it with sines instead of coses, right? And then we find P3y after. So I just push second enter in my calculator. Switch all my coses to sines. And now we have the answer, which is negative 187.5 kilograms kilometers per hour. Oops, that's cut off the screen. Okay, so what I'm going to do is I'm going to finish it up like we did before. I'm going to do it up here. And I'm going to draw our triangle. So the x is 24.75. Oh, sorry, the y is 87.5. And then the x is 24.75. So I'll just do that a little bit smaller. And then this right here is our total y, or a total 3. So I got to go 187.5 squared plus 24.75 squared, and I square root it, so I Pythagoras it, pop that open into my calculator. So grab that. Get rid of the negative because it can screw up your answer. The negative just tells us direction. Add on the 24.75, but obviously use the full answer. Square it, and then square root that. And we get that. But you have to remember that that is just our momentum. So if we want of a speed, we have to divide it by the mass, which is 2.5, which they gave us in the question, and we get 75.6 kilometers per hour, or 75.7 kilometers per hour. Okay, we also need a direction because it asks for that. So tan negative 1 of opposite over adjacent, so tan negative 1 of the 24.75, but obviously use the whole answer, divided by 87.5, 187.5. And we get that as our angle, 7.5 degrees, and we're not going south, we're going east of south. So that's how you do that one. Okay, and hopefully you got that as your answer as well. So this is your homework. These ones here are the right angles. These ones are not right angles. And then number 4 is a challenge question. I'm not gonna test you on one that hard, but you can try it. And then that's your unit review right there. Okay, so let's try a couple sample diploma questions. So pause it. Make sure you try these before you see me do it. So in a movie stunt, a car and a train are unintentionally crashed. The collision is illustrated below. So a lot of people get tripped up by this immediately before the collision when they read that. But you have to remember that our momentum before equals our momentum after. So we find the momentum of our train car. It's going that way. We find the momentum of our car. So if we add those together, well, we can't just add them together normally, but we can Pythagoras them together, and that's how we add them together. That's how we find it before. Right? And we know that P equals mv, so if I go 5 times 10 to the 4 times 10, I can find my momentum is 5 times 10 to the 5. And then for the car, It's in kilograms meters per second for the car. If I want to find my momentum, I go 1.2 times 10 to the 3 times 25. I can't quite do that in my head. So when I do that, I can find my momentum, which is 3 times 10 to the 4 kilograms meters per second. Okay, and then all I have to do is add them Pythagoras style. So I would take my y, which is the 3 times 10 to the 4, my x, which is a little bit bigger, 5 times 10 to the 5, and then that's going to be my total momentum before, right? Or after. It doesn't make a difference. So I got to find that angle there, and I got to find my resultant. So I'll open up my calculator, clear this. So 3 times 10 to the 4 squared plus 5 times 10 to the 5 squared. Square root it, and I get 5.01, right? So it's got to be A or B as the answer, and I got to find that angle to figure out which one is which. So tan negative 1, 5 times 10 to the 5, divided by 3 times 10 to the 4. And, oh no, 86.56, that's not one of the answers down there, but no fear, just go 90 minus, because we found the opposite angle. So just go 90 minus your angle. And it was, the one that I found was going to be east of north. Well, now it becomes north of east, 3.43. We got it. We got the correct answer. So the correct answer to this one is B. Okay, one last one. Lump of clay moving north. Find the momentum of that. 2 times 6 is 12. 8 times 4 is 8. And it's easy. Just got to take those, add them tip to tail. So that's 12. That's 8. That's my overall. Right? And if we Pythagoras it, it's not going to be 4 because that's subtracting it. It's not going to be 20 because that's just adding it. That doesn't make any sense. So that can't be an answer. So it's got to be 14. And it is 14 if you Pythagoras it in your calculator. Now we also know that to find the angle, we can tan negative 1 of 8 over 12. You can do that, and you probably would. But we can also look at this and figure out our answer, right? The 12 is bigger than the 8. So if I take a look at this, that looks like 12 and 8. Those are the proportions that would work. But if I try with C, right, that doesn't work because it looks like our y is bigger. That one's longer, that one's shorter, and that's not what we want. D is the correct answer. When you tan negative 1, you'd end up getting, what is that, 34 inside of there. So yeah, that one's got to be 56.